Hooray! We are ready for that exam. Couple more review videos and hopefully we're good to go. So, our quick topic tonight, one of the things we're going to talk about is adding and subtracting fractions. Okay, so off to the side here I've said find the common denominator, rewrite each fraction with the same denominator, and then add or subtract only the numerators. So the first thing I'm going to jump in and do is factor this bad boy. So I've got x over x plus 2 and x minus 2. I've got a minus 6 on top. I'll quickly factor this. So I'm thinking x plus 10 and x minus 2. Now if you look at these denominators, I have a plus 2, a minus 2, a minus 2, and a plus 10. So I'm thinking I need an x plus 2, an x minus 2, and an x plus 10. So the first thing I say is, what is the first fraction missing? And I would say it's missing the x plus 10. So I'm going to multiply both the top and bottom. Remember, I got to balance it out by x plus 10. Now the second fraction I would say is missing the x plus 2. So I'm going to multiply both the top and bottom by x plus 2. Now I'm just going to real nicely rewrite what I've got, nothing fancy. I've got an x, I'm not even going to multiply, x plus 10 on top, and all three denominators, x plus 2, again don't multiply, x minus 2, and x plus 10. I've got a minus, the 6, and now the x plus 2. Okay, now that I've rewritten the same fractions with the common denominator, I'm just going to write them as one fraction. So I'm going to keep my three denominators, x plus 2, x minus 2, and x plus 10. I'm going to multiply the top, so that's x squared plus 10x. And if I multiply here, that's 6x plus 2. Now don't forget you have to distribute that negative. So I'm going to get negative 6x, I'm sorry, that's 12, minus 12. And now I'm almost done. I'll put my like terms together, so I've got x squared plus 4x minus 12 over the, and again, I'm not going to multiply because I'm hoping in the end something will cancel at the very end. And I can factor that numerator. I'm thinking 6 and 2, so x plus 6, x minus 2. And you should see that the x minus 2's are going to cancel nicely. So my final answer is just the x plus 6 over the x plus 2 and x plus 10. And sorry, I'm squeezing it in there. Now, the next one are called fractional equations. The main difference is that equal sign, and when I see the equal sign, I'm going to eliminate the fraction. So I'm not going to multiply it to the top and bottom, I'm just going to do it to every term. So I factored, and I'm looking at the denominators, and I would say everybody gets an x and an x minus 7. And again, I should kill the fraction this time. You are eliminating the fraction when there's an equal sign. So those cancel, and I've got an x and an x minus 3. Notice I'm not multiplying yet, I'm just writing down what I get. The x's cancel, and I have negative 1 and x minus 7. And then those cancel, and I just get 28. Then just take your time and clean it up. So that's x squared minus 3x minus x plus 7. I'm going to bring the 28 over. Minus 28 equals 0. I've put my like terms together again. Factored x minus 7 and x plus 3. Tee it up. I should get x equals 7 and x equals negative 3. Now don't forget you've got to check, and by checking we're saying what can x not be? Well, if you look at your denominators here, you can't get a 7 or a 0. So as long as you didn't get one of those, we're going to keep it, but I did get a 7, so I'll have to reject that answer, and I'm only going to go with negative 3. Now I am going to switch gears on you. If I went too fast, pause it, rewind it, and we're going to talk about the equation of a circle. And remember, a circle has a center of HK and has a radius of r. And this is that general formula we should know. X minus h squared plus y minus k squared equals r squared. And just keep in mind, everything is squared. So, I'm given this first example, and I want to write the equation of the circle. So the first thing I say to myself is, remember, it's x squared plus y squared equals radius squared. So I'm going to substitute in what I can. So I'm going to say this is x minus 3 squared. Remember, you change that sign. Plus y plus 4 squared equals, now be careful, it's radius squared. Notice it was squared, squared, squared. If the radius is radical 2 squared, of course, is just the number 2. So I can replace that with a 2. Same idea for the next one. Again, I just want to write the equation of that circle. So I'm going to say this is x plus 2 squared plus y minus 1 squared equals, I'll squeeze it down here, Remember, it is radius squared, so I'm going to set that equal to 16. Alright, so our goal this time is to find the center and radius given this equation in standard form. So you can see that I've already rewritten it out. I've got the x squared minus 6x plus something, plus the y squared plus 10y plus something, equals the 66, and don't forget you have to add those two somethings to the other side. So basically, we complete the square twice. We take that middle term, that negative 6, divide it by 2, which of course is negative 3, and square it. You should always be getting a positive number when you square something. So I get 9. So I'm going to add 9 to this side and to this side. Then same idea with the y's. I'm going to take that middle term, positive 10 divided by 2 is 5, square 5, and you get 25. Add that to both sides. Now basically all you got to do is factor this term here. And if you ever get stuck, it's always the number you squared. So I've got x minus 3 and x minus 3. And again, I have to factor this term, and it's always the number I squared. Y plus 5 and y plus 5. And then I simply just rewrite that as that term squared. X minus 3 squared plus y plus 5 squared equals 100. Okay, and lastly, I just need to state that center and radius, so be real careful. I would say if I'm looking at a negative 3, that tells me the center is positive 3, negative 5. Now remember, it's this chunk squared plus this chunk squared equals my radius squared. My radius squared is 100, which makes my radius then 10. Alright, our last quick example here is a complex fraction. So again, that common denominator is a huge deal tonight. I just want to state the common denominator here. Now take a stab at it. If you're wrong, that's okay. You'll quickly find out. So I carefully look at all my numbers, remember, and I'm wanting a number that they all go into. So maybe your gut rushes to 12. Does 2 go into 12? Does 3 go into 12? But does 8 go into 12? Heck no. I gotta come up with a number they all go into. And I guess my best guess is 24. Now, if you're wrong, you'll quickly find out, like I said, that you won't kill the fraction. Well, 8 goes into 24, 2 goes in there, 12 goes in there, and 3 goes in there. So I know that works. Now let's talk variables. I needed to kill every single fraction. I got to pick the same thing. If I just do an x, would that kill this fraction down here? I don't think so. So I think I've got to go with x squared. And again, I'm going to give that 24x squared to every fraction. Okay, I'm killing the fractions, I'm giving it to every one. And then I'll quickly cancel. 8 goes into 24 3 times, so that leaves me with 3x squared. Then there's a minus sign. 2 goes into 24 12 times. X into x squared, just x. 12 into 24 is 2, and then I lose an x. Again, a minus sign. 3 goes into 24 8 times, and the x squareds are gone completely. Lastly, factor before you do anything. Bottom, I can pull out a 2 as a GCF, and I get an x minus 4. On the top, I can pull out a 3x, and I get an x squared minus 4. Whoops, and I caught myself. That should just be a 3x, not an x squared if I took that x out, which is very nice in my favor because that's going to tell me that these x minus 4s are going to cancel. And lastly, you'll notice I just have a 3x on top all over a 2. Well, here they are. There's your 5 questions for the night. We look forward to seeing any answers and any questions you may have. Catch you later.